Number 49, we start talking about the margin of error, and we're going to apply that to make an interval, right? And so remember that we can get the exact numbers from a sample, but if we want to apply this to a whole population, we have to give ourselves an interval for a little bit of wiggle room, okay? Because we don't know exactly what our information is about a population. So this says, before the Thanksgiving holiday, in a survey of 2,368 people, 85% said they are thankful for the health of their family. Aww. Okay, what is the margin of error for the survey? Remember that our margin of error is 1 over the square root of n being the number of people surveyed. So we have plus or minus 1 over the square root of 2,368 people, which is approximately 0.02 or 2%. But now we want an interval. Okay, so this is the give or take 2%, right? So if the average is 85, then I gotta go 2% this way and 2% this way. So my interval is 83% less than or equal to mu, because I'm talking about a population now, and then add the 2%. Okay. Number 50 is basically the same question, same kind of question. In a survey of 1,022 U.S. adults, 76% said that more emphasis should be placed on producing domestic energy from solar power. Okay, margin of error, 1 over the square root of the number of people. So this is about 0.031 or 3.1%. So now I need to take that 3.1% and subtract it from 76 and add it to 76. So this gives me 72.9% less than or equal to mu, less than or equal to 79.1%. Okay, number 51. All right, okay, so now they give us the interval and they want us to find the number of people that were surveyed. So from the interval, we can find the middle, so we know the give or take, which way, or how much it goes in either direction. So there's a couple of different ways we can do that. I know if we take the whole interval and cut it in half, then we know what the margin of error is, right? So if I do 66.7% minus 57.3%, and also this is not how I did it on the key, but that's okay. It's nice to have a couple of different ways. So this is 9.4%, but then I cut that in half. So my margin of error is 4.7%. Okay. Well, my margin of error formula is this, right? And I need to find n, and I just found the margin of error, but I need to put it in decimal form. So 0.047 equals plus or minus 1 over the square root of n. And I can switch these two. If you want to know why, you can come talk to me and I'll tell you. And we end up with the square root of n equals 1 over 0.047. So n is approximately 453 people. Okay, moving on. All right, on a day, on day 2 of a study on body temperatures, 106 temperatures were taken, that's a lot. Suppose that we only have the first temperatures to work with. The mean and standard deviation of these 10 scores were 98.44 degrees Fahrenheit and 0.3 degrees Fahrenheit respectively. Construct a 95% confidence interval for the mean of all body temperatures. Okay, so this is very similar to what we were just doing with margin of errors, but this time we can actually put a confidence level with it. Okay, and we are going to use, instead of 1 over the square root of n, we have z, which is our confidence, is our z value, which gives us our confidence number. And it is times s, the standard deviation, over the square root of n. So in this case, we have n is 10. X bar is what we're going to be using later for the interval. That's 98.44. S is 0.3, and Z is the 95% confidence interval number, is the Z value is 1.96. Okay, so now I'm going to plug that in. 1.96 times 0.3 divided by the square root of 10 gives me 0.186. We're going to add that and subtract that to 98.44. So I get 98.25 less than or equal to mu less than or equal to 98.63 degrees. Okay, that's not a lot of difference. Standard deviation, very small. All right, I will finish number 53 and 54